All right, so we've already talked a bit about significant digits and using an instrument to find significant digits. So, to determine how many significant digits we should have based on a particular instrument. And remember, significant digit just means all certain digits plus one estimated digit. Okay, so we have those powers of 10. We know for certain up to a point, and then we estimate one more digit. That's one half of significant digits, finding what significant digits there are based on an instrument. The other half of things is interpreting the number of significant digits in data that somebody else gives you. So that's what we're going to talk about here quickly today. So I'm going to go through a couple of different points about how to interpret significant digits, and then as I do that on a whiteboard, I'm going to give you some specific examples of each of these rules. These are going to be things you're going to need to know throughout the school year, so there's going to need to be a degree of memory. But hopefully, as they make sense to you, memorizing them won't be a problem because they're going to make sense. Okay? All right, and we'll review these in class together as well. All right, the first rule is that significant digits only apply to things that are measured. Okay? Only apply to things that are measured. So if you just have a number, 500. Okay, the number 500. There's nothing about that we can talk about significant digits. There's no unit. It's not a measurement. Okay. If you talk about a pair of socks, okay, or a pair of birds, or a pair of anything, okay, a pair just means two of something. It's exactly precise. There's nothing to do with significant digits there. Okay. Other numbers. For example, a square root or a constant like pi, all of those things, okay, no significant digits, no SDs, okay, because they're not measured. They're not measured, okay, so significant digits don't apply there, okay. Now, another sort of thing that falls under that category are ratios that are exactly 1 because that's their definition. So 100 centimeters is 1 meter. Okay, I don't need to think about significant digits here because that's exactly 1. We know by definition that's what that is. Okay, 1,000 grams to 1 kilogram. Same thing, no significant digits needed, it's exactly equal to 1, okay? All right, so that is our first rule, okay? Now, let's see. Now let's take a look at our second rule, okay? Our second rule is once we know we have measured data, now we can start applying all these other rules. Okay, so the first thing is that any digit that we see in a measurement that's not 0, we're going to assume that that digit in itself is significant. Okay, so anything that is not 0 is going to be significant. So for example, if I tell you that there are 25.4 milliliters in my graduated cylinder, all 3 of those digits are significant. 2, 5, and 4 all are significant. We would say that this measurement has 3 significant digits, okay, because they're all non-zero. Or if I tell you that I used my balance and I found that the mass of an object was 13.78 grams, okay, the 1, the 3, the 7, and the 8, all 4 of those are significant because they are all not 0. Okay, so anything that is not 0 is significant. And then, so that's our second rule. And then our third rule comes with some caveats or some exceptions or some things that we have to think about. I'm calling this our third rule. The book breaks this rule down into a couple different ones. But we'll go through that. So zeros are sometimes significant. Okay, zeros are sometimes significant, and this is when they are significant. So they are significant when they are between non-zero digits. Okay, so 100.5 degrees Celsius. Okay, the 1 and the 5 are non-zeros. They are significant. And then according to this rule, these two zeros, since they're between non-zeros, they are significant. So this number has, or this measurement has 4 significant digits. Okay, another example of finding the mass of something else, 1.09 grams. Again, the 1 and the 9 are non-zeros. Those are significant. And that 0 is between them, so that is significant as well. That would have 3 significant digits. Okay, so there we are. Zeros between non-zeros are significant. Okay, and then the next sort of set of principles relating to zeros has to do with the decimal point. Okay, and whether or not there is one, and then where the zeros are in relation to them. So here is the first rule. If there are zeros to the right of the decimal point, they are significant. And that's one place where we have to be careful when we're using an instrument, that if we add zeros, we're telling whoever's reading our data that this is significant, that I really measured it this far, so we have to be careful about that. So, for example, if I measure the time to be 20.0 seconds, okay, I'm not just saying, oh, it's 20 seconds. 20.0 implies there is precision, that I know for certain those first 2 digits, and I estimated the third, that there are 3 significant digits in that number. Okay, so those zeros are significant. Likewise, if I say there are 250.00 liters, again, these zeros are all to the right. So I have 2 non-zero digits, those are significant. And then everything to the right of the decimal, there's a decimal, and then all the digits to the right of non-zero digits are significant then. So in this case, I actually have 5 significant digits, so quite a few. Okay, now I'm going to go a little bit out of order from your book here and follow the presentation. So we've talked about between digits, we've talked about to the right. What if there are zeros to the left? Okay, what if there are zeros to the left? So for example, 0.075 kilograms. Okay, so here our zeros are to the left of non-zero digits, and there's a decimal there. Okay, we know that 7 and 5 are significant because they are non-zero, but zeros to the left are not significant. Okay, zeros to the left are not significant. So this number actually only has 2 significant digits. Okay, these zeros are what we call placeholders. Okay, these are called placeholder zeros. Okay, so let me give myself some more space here and move everything around a bit. There we go. Okay, so let me give you another example here. What about 0.0010 seconds? What if I've made that measurement? Okay, I know that the 1 is significant because it's not 0. Okay, the 1 is significant. The ones I have to be concerned with are the zeros. Okay, we know that zeros to the right are significant, and then the rule we just learned is that zeros to the left are not. So those 3 are not significant. The one to the right is, so that gives us a total of 2 significant digits in that measurement. Okay. All right, so we dealt with right and left of the decimal. Now, what if there is no decimal? Okay, what if there is no decimal? Okay, I'm going to go ahead and see if I can move all of this up here. Maybe not. I'll just get rid of some of this stuff. All right, so if there is no decimal, then we go back and look. If there are zeros to the right, and there is no decimal, those zeros are not significant. Okay, so here 2,500 milliliters, the 2 and the 5 are both significant because they are not 0. But these zeros, there is no decimal point here. Okay, so those zeros are also placeholders. They are just telling us, they're just getting us out to the 2,500 range. Okay, so they are not significant. We don't know for certain what those digits are. Okay, and so this measurement would have two significant digits because those zeros are not significant. Okay. Now, if we wanted to imply that this was significant, we would add a decimal. So if we said 2500 point milliliters, now those zeros are all significant. Okay. Now all four of those digits are significant for significant digits for that number. So that decimal point really plays an important role. Okay. All right. The very last thing we want to talk about here is the scientific notation. Okay, so sometimes you have to use scientific notation in order to show your significant digits. So, for example, we'll just take a look right here at this problem that we had. There we go. And move that up. Great. Okay, so taking a look up here at this number, 2,500 milliliters. Okay. Suppose I was able to measure to the I know for certain the 5, and then this 0 actually is significant. Let's say I estimated that 0, and I need to show that. Well, as it is, there's no way to show it as it's written. What I have to do in this case is put it into scientific notation. Okay, scientific notation is a number. Okay, and it's got to be a number that only has one digit to the left of the decimal place. Okay, and then it's multiplied by a power of 10. Okay, so it's a number and then a power of 10. This part actually has a special name. It's called the mantissa. That's just a bonus for you. That's some number between 1 and 10. It's got to be less than 10, a decimal or not, okay? And then a power of 10 with an integer there. An integer is 1, 2, 3, -1, -3, -10. There's a whole number, either positive or negative. Okay, now the key thing is that the mantissa includes only significant digits. Okay, so if a digit is not significant, it should not be included in the mantissa. So in this case, you have 1, 2, and 3 significant digits. Okay, versus up here, where I had 2, or here where I had 4, this implies a different kind of precision than the other two. And in this case, I had to use scientific notation. Okay, so that wraps it up. For those rules, again, that's interpreting significant digits from a given measurement. The last thing we'll talk about in the next video is how to do calculations with these measurements.